You're listening to AI Podcasts. Today we're digging into a new EMNLP 2025 paper called UI Hawk, which is all about teaching GUI agents to understand the flow of screens on a phone, not just a single screenshot.
Like letting the agent watch a whole movie of your taps instead of a single freeze frame.
Exactly. The quick takeaway? When the model remembers what earlier screens looked like, it makes far fewer mistakes. UI Hawk adds a history-aware visual encoder and a smart way to pack more visual tokens, and that leads to big gains on tough navigation tasks.
Who's behind it?
The team is led by Jiwen Zhang and Yaki Yu, with collaborators from Fudan University and Huawei. They also released code and a benchmark, which is nice for the community.
All right, set the scene for us. What problem are they trying to solve?
Most mobile agents decide what to click based on the current screenshot, plus a plain text log of past actions. That text history is like reading a travel diary without any photos. You lose the visual clues that actually matter, like where a search bar was on the last screen or which product you already opened.
So the gap is memory, but specifically visual memory across time.
Right. The authors call it screen stream understanding. Instead of treating screens as isolated images, UI Hawk processes a sequence so it can use what it saw 2 or 3 steps ago.
How did earlier work fall short here?
A lot of prior agents were either pixel-only on the current screen or relied on structured data like accessibility trees. Some newer ones kept a text-only history, which is compact but lossy. If the decision depends on what an icon looked like on a previous screen, a text summary won't cut it.
Got it. So what's their key idea?
2 parts. First, a history-aware visual encoder that ingests multiple past screenshots and tags them as history screenshot 1, history screenshot 2, and so on. That makes the temporal order explicit. Second, an efficient resampler that compresses visual tokens by about 16 times, so you can fit several screens into the model's context without blowing the budget.
The compression matters because mobile screens are huge, right?
Exactly. Phone screenshots are high resolution and varied, so you need to keep the fine details, like small icons and labels, but still run efficiently. The resampler plus the positional encoding gives UI Hawk both memory and precision.
And how do they train it to care about the right things?
They stage the learning. Think of it like teaching a driver the road signs before sending them into city traffic. First, they train on 4 fundamental screen skills: grounding, which is pointing to the right spot, referring like tap the blue button under the search bar, screen question answering, and summarization of what's on the screen. After the model gets good at those basics, they fine-tune it on sequential navigation tasks where it has to chain actions across apps.
I like that curriculum analogy. It's building the vocabulary, then practicing full sentences.
Exactly.
You mentioned a benchmark earlier. What did they release?
It's called Fun UI. It's bilingual with English and Chinese mobile screens, and it tests those 4 fundamentals. The point is to measure the basics that underlie navigation, not just end-to-end success on a single dataset.
That's useful. End-to-end scores can hide whether the model actually understands the interface.
Right, Fun UI surfaces whether a model can identify the right widget, answer a practical question about the screen, or summarize what's visible.
Okay, let's talk results. How much better is UI Hawk in practice?
On a cross-app benchmark called GUI Odyssey Plus, UI Hawk scores roughly 9 points higher overall than a strong baseline called Odyssey Agent. And on click accuracy, which is a direct measure of grounding, it jumps by more than 30 points. That suggests the history modeling really helps the model land the right tap.
Those are meaningful gains. What's a real-world example where that history would make the difference?
Picture this. You search for hiking boots in a shopping app, open a product, then back out. When the agent needs to choose the right filter next, it helps to remember which filter panel it just saw and where the sort by price option was. Without the visual memory, it's easy to wander or click the wrong back or menu that looks similar.
Or when you switch apps in the middle of a task. Say, copy an address from a message, open Maps, then paste. Remembering what the message screen looked like helps the agent find the right conversation again later.
Exactly. Long horizon tasks are where memory pays off.
Any interesting engineering details we should call out?
A couple. They build on a document-focused model called TextHawk, adapt it with a detection head for bounding boxes, and use LoRa to fine-tune the language model. And they use scalable positional encoding, so the model knows which parts of each screen map to which tokens, even when resolutions change.
Nice. What about the experimental setup? Anything we should be cautious about?
The authors do follow the community checklist. They include a limitations section and report the compute and setup. One caveat is that, for the fundamentals benchmark, they sampled a subset of examples per task due to evaluation budget. That's reasonable, but you always want to see full set results when possible.
Right, smaller samples can hide edge cases. Did they say anything about data creation?
Yes, they describe an automated data curation pipeline for building the fundamentals training sets. That's practical, though any automated labeling brings questions about noise and bias, so replication details will matter.
How about generalization? It crushes GUI Odyssey Plus, but what happens on totally new apps or different platforms?
That's the open question. The paper's story is convincing on Android cross-app navigation. The next step is broader tests across operating systems, devices, and UI styles, plus web UI. If the history modeling is the main driver, we'd expect it to carry over, but it needs to be shown.
And I'm guessing people will also ask about efficiency. Keeping a full visual history sounds expensive.
It can be, but that's where the 16 times compression comes in. A practical research direction is making dynamic memory, deciding how much history to keep and at what resolution, so you get the benefits without the cost every time.
Any notes on openness and reuse?
They release code and data, which is great. The checklist also hints that license discussion for all artifacts could be clearer. That's a common pain point, and tightening those terms would help downstream teams adopt it.
If you had to explain the core innovation to a product manager, how would you phrase it?
I'd say stop treating each screen like a Polaroid. Treat the session like a film reel. UI Hawk gives the agent a compact, memory-friendly way to keep earlier frames in mind, and then it trains the agent on the basic screen skills before asking it to navigate.
And to a designer?
Your users rarely complete a task in one shot. An agent that remembers where it's been will make more human-like choices, like going back to the right panel or reusing the right search. UI Hawk is a step toward that.
Any final concerns you'd flag?
2. First, robustness across unseen apps and updates. Interfaces change, and we need tests that reflect that churn. Second, reproducibility at different scales. It would be great to see distilled variants that run on smaller budgets or even on device.
So, quick wrap-up?
UI Hawk shows that modeling the screen stream, real visual history, changes the game for mobile agents. The architecture is efficient enough to make that memory usable. The fundamentals first training sharpens the model's instincts, and the results on navigation are a solid jump.
And the to-do list for the field is clear. Broaden the evaluations, trim the compute, and keep the artifacts easy to reuse and audit.
That's the story. If you work on app automation or multimodal agents, this paper is worth a read and a try.
Thanks for listening to AI Podcast. We'll link to the work in the show notes. Until next time.
See you next episode.